COVI Lecture Series presentation. This afternoon, we're excited to welcome Dr. Jim Willwerth, Assistant Professor of Biological Sciences here at Brock and COVI researcher. The major component of his research program is focused on grapevine cold hardiness physiology, understanding how to maximize cold hardiness in Vitis vinifera, and to further understand woody plant cold hardiness physiology and the associated response to environmental conditions during dormancy. He also has an extensive program focused on grapevine evaluations and how genotypes can impact cold hardiness, vine performance, and wine quality. Jim has a decade of experience with effective technology transfer to the grape grower community. He is currently past chair of the American Society for Enology and Viticulture Eastern Section and sits on several Ontario grape and wine industry committees. Please join me in welcoming Jim.
Thank you very much for the kind introduction. It's great to be back here for the COVI Lecture Series. I missed out on last year, but I'm really happy to be back for 2023 here. And today I'm going to talk about improving resiliency in grapevines to avoid freeze damage in a changing climate. But I'm going to talk even more about just freeze damage. I want to talk more about, the use of different plant material and how some of our evaluations that we're doing here and some of our cold hardiness research fits into, having an adaptive strategy to a changing climate and tie it in with what's happening worldwide as well. So look at it from a global standpoint in terms of wine growing and bring it right back here to Niagara and Canada. So when it comes to cool climate viticulture and changing climate, we have to realize what we're dealing with our cool climate regions. And many of our cool climate regions are very diverse. And at the same time, they can have a wide range of conditions and climates. So our growing conditions can really vary, and they can be short. And we do get different vintage effects that impact that as well. We have a wide range of soils. Just even the Niagara Peninsula alone, we have a lot of different soil types, fertility, drainage, and depth. And all of this can impact vine performance as well as quality and our choice of plant material that we're using, particularly our rootstocks. Precipitation timing events can vary both regionally and seasonally. And so this is a big difference here too across our growing regions. If you look at British Columbia, for example, there's a lot more irrigation, more arid climate, particularly, Canada's only desert in the Okanagan Valley, for example. Whereas where we are here in Ontario, in Nova Scotia, Quebec, and so on, our precipitation can vary a lot. And we can have frequency of precipitation that can vary a lot as well during the season, with either wet periods in the spring, summer, or the fall, or even periods of drought, particularly between June and August. One of the limiting factors in all of our cool climate regions, and in Canada certainly no exception, is the limiting winter temperatures can vary and they can be extreme. So, we're really limited by what we can grow based on our minimum temperatures. And we can have a lot of extremes, and with climate change, this was probably going to be exacerbated with the amount of extremes we may see, and that can include some of those things that I've talked about, including drought, high rainfall, just more overall volatility, and also extreme cold. As I mentioned, we do have some irrigation in some of our regions that can help mitigate some of these effects. But with climate change, ultimately, and I'm going to show you some data to support this in the talk, is that with climate change, it's going to ultimately help remove these goalposts a little bit when it comes to heat summation during the growing season. We might get shifts in phenology, and we may have more volatility and extremes that we have to manage. And this is where the resiliency of the plant material really comes into play, and having material that's matched for your site. And so this is an older slide, but it shows you, or an older figure, but it shows you, in terms of what the climate requirements are for some particular grape varieties. And they can be lumped into different groups here based on the average growing season temperatures required for maturity. And they can also be further broken down, depending on the climate model that you're using, based on Veraison or heat units from Veraison to harvest, for example, and so on. And you can see a lot of our cool climate regions are more in this area of the spectrum, compared to late maturing varieties like Zinfandel and so on. And you can see that in terms of looking at the optimal ranges for maturity, they can vary quite a bit. And some varieties can have a wide range, like Riesling, It can grow under many different conditions, and Chardonnay is also very similar in that respect, and they can be a little bit more versatile. And that's why some of these cool climate varieties are very popular, right? And we actually consider them cool climate varieties, and they're found in many different regions worldwide. So when we start to get a shift in climate, it can impact changes in growth and development of the vines, as well as the fruit maturity, fruit composition, and as a result, wine quality. So this is where even very small changes in climate can impact the characteristics of wine from one year to the next even. And this is where we start to get to these vintage effects. But if we start to have long-term climate change, and we're getting considerably warmer temperatures throughout the growing season, warmer temperatures at harvest, or leading up to harvest, this is where we can get long-term changes in wine styles and so on. And so this is where a lot of the adaptation strategies are being developed to try to mitigate, high alcohol wines with that have atypical flavors, and so on. And so we might start to see these, as I mentioned, these goalposts shift a bit and really start to change the maturation and the climate of what's happening at key developmental stages. And so here's just an example, like looking at different phenological stages of vine development. So looking from bud burst through flowering, veraison, harvest, and then obviously dormancy plays a big role, particularly in some of the research I'm doing with respect to cold tolerance. And so if we get changes in volatility in the climate in any of these different key times, from winter all the way through autumn and throughout the season, it can have an impact on the developmental stages of the vine. So for example, if we get extreme weather in winter months or volatility, we might have impacts on cold acclimation. We might get winter and freeze injury that can impact production and yields. Conditions that change during the spring period, either wet, dry, too hot, too cold, will impact that initial growth of the vine and the growth of the canopy. Flowering, environmental conditions are extremely important during the flowering period in terms of bud initiation for the following year, so fruitfulness of the vines for the following crop, for the next year, as well as berry formation and fruit set for that particular growing season. Veraison harvest is during the period where the fruit's maturing. So if we have dry conditions or stress conditions on the plant, it's going to have an impact compared to if it's really wet conditions, right? So all of these extremes, all this volatility can have an impact all through the season, and it can impact yields, can impact quality, can impact vine health, and so on and so forth. This is a nice slide from Dr. Jones from Oregon, and this is just looking in terms of just some climate metrics, such as growing season temperatures, heat accumulation, and so on, and how it can relate to things like yield production and wine flavors. So if we're too cold, we can have lower sugar levels, unripe flavors, unbalanced. We can also have lower production. Too warm, and we're in a different threshold where we're going to have, again, lower yields, but we might have overripe flavors and unbalanced flavors. And this optimal area, an optimal zone, is going to be more that consistent area of development of the fruit, good balanced yields, and so on. Here's some data that I just want to do a snapshot looking at what's happening in some regions worldwide. And here's an example of long-term evolution of vine phenology. And this is looking at Riesling in Alsace. And Alsace is one of the regions that seems to be being impacted a lot through changes in the climate and shifts in phenology and shifts of what the temperatures are during maturation and so on. And you can see here, with whether it's bud break, flowering, veraison, or harvest, that some of these phenological events are getting earlier and earlier over time since the 1950s. And so this is having an impact on things like potential for spring frost damage and so on. Even though if you're looking at models, different papers will tell you, or different studies will tell you some different thoughts about the risks for spring frost, but especially in the long term, but right now it does seem like there are some increasing frost risk due to earlier bud break in a lot of regions of Europe. And the Europeans have a lot of great information because they've been collecting this data since, in this particular case, since the 1800s in terms of harvest dates and so on. And so you can see that there's a trend, particularly from the late 70s and 80s, where we're seeing earlier and earlier harvests. And so maturation is the rate of maturation in these phenological stages are changing and shifting and getting earlier. So this has an implication in terms of on things, including even winter hardiness, because of the shifts in when things are happening. I really like this this figure. That's why I wanted to include it, because this takes into consideration not only how harvest dates and so on may be earlier for different varieties in a region that has a lot of historical harvest data, but it also takes into consideration the temperatures that are being experienced during these different stages of harvest and so on. And so if you look at the different colors, if you see red, that is the warmer temperatures, and if you start to see greens and blues, those are cooler temperatures. And so in a nutshell, if you look at some of the earlier harvests that were in Bordeaux, you see that Sauvignon Blanc, Merlot, Cabernet Franc, and Cabernet Sauvignon were occurring later in the fall period, and during periods where the temperatures were cooler. And so, you know, historically, and in the research community, those that study the terroir effect, they really feel that if you want to optimize terroir of a region, it's a cultivar that's going to mature at the end, at the very end of the growing season. And that's when it's truly matched to the climate and where the expression of those grapes are going to be at their maximum and to give you that regional identity. And so you can see historically in Bordeaux, this is what was happening. And then from the 80s to 2010, you can see some of this data. And you see that the harvests are getting shifted and moving earlier, and also happening during some warmer temperatures. And if you look at this model and you add just 1 degree Celsius, you see that this gets shifted even more in terms of the harvest dates for these different Bordeaux varieties. And again, getting shifted into more and more warmer periods. So you can imagine how that's going to impact vine development, how it's going to impact the fruit development specifically with respect to the flavors that are developed and so on and so forth, sugar levels, and how that can impact the style of the wine. You know, so, you know, a typical adaptation strategy here would be if you want to grow these varieties, well, try to find a variety, or not a variety, but try to find a selection, a clone, or that might be later maturing. You know, find or utilize a rootstock that might push development back and delay some of these advances in maturity. And this is where planting, and then also cultural practices. All of these types of things can come into play. Now, I gave you some European examples, but what's happening, you know, in terms of climate change and grape growing in Canada? Well, some studies have shown that we will see a rise of average temperatures, more heat waves and days above 30 degrees Celsius, higher drought incidence, reduced snow cover and increased rainfall in winter, and more extreme weather events. I mean, if you look at this past winter and you look at the past few seasons, you know, might not be too much of a stretch here, especially when we start to talk about reduced snow cover, rainfall in the winter. I mean, this was a perfect example of that. But then we can also have these extremes where we have the polar vortex. We've talked about, you know, all these you know, really catchy names like a heat dome that was in BC that impacted production and so on. And so ultimately when we're farming, we are farming these extremes, but then we're also farming this volatility and these shifts in the climate as well. And one of the advantages that we do have, particularly in Niagara, let's use Niagara as an example here in Canada, is the Great Lakes. The Great Lakes have a huge mitigation impact here when it comes to our climate. We're able to grow grapes and tender fruit in the Niagara Peninsula because of our Great Lakes. If the Great Lakes did not exist, we would have very cold winter temperatures, and none of the tender fruit or grapes that we grow would survive. And one of the things that we're starting to see, and I've been following this more and more particularly living closer to the lake, and looking at ice levels and so on. And so this particular year, if you look at the data from February 14th of this year, we're at the lowest ice coverage of the Great Lakes historically since over the last 50 years. And so if there's no ice cover, yes, it can bring more extreme weather during the winter months. That's not really going to impact grape production, I don't think. But the problem is that if we get warmer and warmer lake temperatures, it may help push bud break earlier. We may not get as cold of winters, but it may shift our phenology a little bit in our vines. And it may also reduce some of the cooling effects in the summer months. When we have these really hot 30+ days, if the lakes are very, very warm, they might not mitigate, and cool our climate around our regions as much. You might start seeing hotter temperatures. Those are all theoretical in terms of how the changes in the lake can impact our growing seasons and also our winters. Just get rid of that cursor. So there's a number of different adaptation strategies in viticulture. And, I'm not going to talk about all of these, but a number of them can be done and will be done out of necessity. So, and we're constantly doing this anyways in terms of cultural practices, canopy management during the growing season, because one season can be much different than the next. One season might do more leaf removal than another one, and so on. So what are some of these adaptation strategies? And some are going to be short-term, some are going to be more long-term. So when it comes to long-term strategies, there's things like training system are one way. There's also different adaptation strategies that can be done in the short term, such as canopy management, changes in cultural practices. We may have new freeze mitigation strategies. A perfect example for us here in Niagara has been the use of wind machines, right? It's allowed us to expand our regions and have more sustainable production, for example. Irrigation will help, and especially in regions that are going to go drier and have more prolonged drought. We might see expansion of regions, right? We're seeing that worldwide in terms of moving to higher elevations, expanding to areas that are, non-traditional regions for growing grapes. And then what I want to talk more and more about is plant material. So selecting plant material, breeding, evaluation of plant material, and then I'll talk about a final one that we're working on here in Ontario is the use of plant growth regulators, in particular the plant growth regulator that can help maintain dormancy to help avoid freeze injury. So here's an example of some of these different strategies and really kind of fit in the time frame of things. You change your winemaking technique, and winemakers do this every single year. Timing of harvest, soil management, canopy management, pest and disease control. These are more short-term adaptation strategies. Then if we start getting into ways we're planting the vines, training the vines, pruning the vines, that's more long-term, as well as site selection, and then new plant material and irrigation can be considered more long-term. So if we're talking about plant material, this is what I'm going to be talking about for the next little while, and specifically how plant material can be an important resource for climate adaptation. And this includes everything from trials that are going to optimize the quality and the performance of vines within a region at any given time, or potentially used in the future to help as a climate adaptation strategy. And so when we're talking about different plant material, it could be species or crosses of different species and the introduction of new cultivars completely. It could be traditional cultivars, indigenous cultivars to a region, as well as clones, which are specific selections within a cultivar, or the use of rootstocks for our grafted vines. And also the quality of material cannot be ignored. And you've heard a few lectures during the lecture series concerning different grapevine viruses, and you've learned how that can impact the quality. And if your vines start off being diseased, they're not going to be as adaptable and as resilient to stresses, whether they're abiotic or biotic, all of which can be, again, exacerbated by climate change if they have presence of virus. So if we're looking at cultivars, and this is where we can have some adaptation strategies by choosing different cultivars, breeding new cultivars, and so on. We have a lot of them. There's many different vitis species. We have a lot of different vinifera cultivars, and we have a lot of intervarietal diversity, which includes clones and ecotypes within these major cultivars. We also have a number of different interspecific hybrid varieties, and more of those being produced to deal with some of the climatic challenges that we have in some of our grape regions. And as I showed you before, in terms of the cultivars, they do have differences with respect to growing season requirements and maturity requirements. They're also going to have a lot of differences with respect to how they get ready for the winter, right? How they acclimate, how they respond to changes in temperature during the winter, and that includes how they reach their maximum hardiness, how maximum hardy they can be, how they lose hardiness or how they deacclimate, and also then their growth habits and so on. And when it comes to these different cultivars, again, they're going to be, they evolved in a particular climate. So if you take them out of that environment, they may respond a lot differently and may impact how they ultimately perform. And so in some cases, we don't really know how these cultivars will really do until you plant them somewhere else, you know, until you have that experience, expose them to those cold temperatures. How hardy will Albarino get, you know what I mean? And so this is something that where regional trials come into play, and I'm going to talk about that on multiple fronts here. Now, rootstocks, as you know, we have the scion above the ground, and the rootstock is the grafted part of the vine that is below the ground. And rootstocks traditionally were developed to deal with phylloxera and to ensure that vines can have some resistance, or at least tolerance, to some of these biotic pests like phylloxera and nematodes. A lot of these rootstocks, they're not really resistant, they're just tolerant. And then also tolerant to different abiotic stresses, and that can include, water stress and so on. Different rootstocks can control the growth and shorten even the vegetative cycle, and also and control the uptake of nutrients. Now, we're talking about clones. There's been clones that have been selected for a very long time, and we look at some cultivars like Pinot Noir, for example. It mutates, seems quite readily or rapidly, and there's a lot of different clonal selections. And so, since grapevines are propagated vegetatively, we can have this clonal selection and have vines that have differences in their morphology, in their color and their flavor and so on, and produce them and propagate them so they're actually true to type. And what are some of the characteristics of clones that are of interest? Well, earlier and later maturing clones are one. And I used that as an example within Bordeaux, and looking at, if you're getting a shift in harvest dates, and differences of maturation happening at different periods of time where they're warmer. Hey, if you have a later matured clone, could that be used as an adaptation strategy? And I've actually found some data from Bordeaux where they actually have looked at some different Cabernet Franc clones. I think it's Cabernet Franc. Anyways, it's one of the Bordeaux varieties, and using these clones and showing how some of them can be later maturing. And so that's something of interest here, that maybe, in some of our cooler climate regions, newer regions, maybe an early maturing clone might be better. And so this is where clones can come in. Growth habits. And we've selected clones here in Ontario, for example. If you look at Paul Boss Sr. Selecting the Gamay Droit clone, which is an upright growing clone, and how that can impact the growth, the management, and even the flavors of that particular Gamay vine. Color and flavor, a classic example, Chardonnay Muscat. There's a Muscat clone of Chardonnay where it can have more muscat characteristics. Then there's also cluster morphology and berry size. You can look at the Maria Feld clones of Pinot Noir, which are very large, not very tight clusters, compared to the thin clones like your Dijon clones, like 667 and so on. Here's an example of 667 actually right here. And you can see how tight clustered it is, small berries, high skin to juice ratio, ideal for red wine making. Clones can also differ with respect to disease tolerance, and something that we've been studying here, cold tolerance. So can we select a Chardonnay vine that's a specific clone that is more hardy than another clone? And maybe that's better for us here in a cool climate region that has cold winters, or maybe we'll find a clone that's more or less susceptible to cold deacclimation, for example, if we're serving in warmer conditions. So I mentioned this before when it comes to viruses. Without any exception, you want plants that are healthy, and you want plants that are going to be resistant to stress. So quality of materials is super important. This is why we have such a big initiative here in Canada with the Clean Plant Program, which Dr. Pujari talked about. That was last week already. Wow. Seems like every time's flying. And so when you're looking at quality of material, you want a good source of material, you want to be true to type, and you want to be clean of major viruses or diseases. And so if we want to have vines that are resilient to extremes in climate, volatility in climate, we want to make sure that it's quality material. It starts right at the very beginning of planting and having good quality material, not to rush planting using poor quality material. So this is where it comes into some of the strategies that we've been working on. And so the second part of the lecture, I really want to focus on some of the things that we're doing here and what's being done a little bit worldwide as well. And so one of the key things is evaluation of plant material to identify different material that's optimal for the region. And so a lot of regions are evaluating new material constantly. And what's happening now is, whether you want to or not, in a lot of even our traditional regions that have been growing the same variety for centuries, it's starting to put more efforts into evaluating new material, if it's new clones, new rootstocks, because if a region that has it's an appellation and it's known for one variety, that kind of changes things if you start to change that variety in terms of consumer acceptance and just the tradition, right? In European regions, the whole cultures around the variety in terms of food, in terms of just what is known and what you live. And so in established regions, there's a lot of focus on different clones, as I mentioned, like looking at later maturing clones, for example, looking at different rootstocks, and then even looking at different varieties and approving of new varieties in appellation systems that may be more adapted to future climates. Then there's also a look of new crossings, in some regions looking more at traditional indigenous varieties, looking at some really old historic vineyards and selecting vines from there, and just other plant sources in general, including new material that's from breeding programs. In particular, some that's has more disease tolerance. And that's what we're getting. Like, we're finding that there's more efforts looking at more disease resistance. We've got the peewee varieties and so on and so forth. And then there's also other problems that we're dealing with as wine regions, and that's, we want to, there's more reductions in terms of pesticides, herbicides, and so sometimes the regions are being forced to change what they're doing. And that's where, again, where rootstocks are going to really come into play. In Canada and Ontario, we've really transitioned from to more vinifera. I mean, if you look at Ontario, we still have quite a bit of hybrid production, and it is an important part of our industry, but we are shifting in terms of some newer hybrids compared to traditional French hybrids. And if you look at a region like British Columbia, I mean, it's pretty much all vinifera now. And so it is important to continue to evaluate material in looking at evaluations of existing material as well as new material in our various provinces and wine regions. And obviously cold tolerance is a major trait that is of interest. And again, as I mentioned before, also clean material. And this material was going to be more adaptable and more resistant as well. But I found this, I thought this was really interesting in terms of this is from a Vitadapt experiment in Europe, and I just want to show you just how cultivar can be used if there is a change in different cultivars and how that can differ with respect to phenology. Particularly, this is looking at veraison. And you can see how these different cultivars will vary. Like, you always think of Chasselas as a really early maturing variety, right? In terms of all the climate models and where it fits in the scheme of things. And so you can see here with dates of veraison, I mean, you got Chasselas way over here. Then you've got varieties like Gamay. We want to focus more on Gamay and some of these cool climate cultivars here. And then you can see where some of these other ones fit in when you start getting into, Sangiovese, you get into Carignan. You look at Cabernet Franc. I mean, so there's a lot of different varieties that can be adaptable to different situations, and this is where this can fit in when it comes to adaptation strategies. And this is an example of looking at different cultivar evaluations and how they perform within a region. But when it comes to building resiliency in grapevines to climate change, rootstocks are certainly one of the best ways to probably deal with severe abiotic stress in a cool climate region. Because we have a lot of opportunities in a cool climate region in terms of even looking at the maturity indices here, and looking at, not really maturity indices, but looking at the timing of veraison, for example, and veraison dates. You could see that if you're down here in the varieties you grow, if you want to push something that's going to be a little bit later because your season's advancing, there's a lot of opportunity, right, in terms of variety diversity that you could choose. You're already up here, and it might be difficult to find a variety to adapt to that region. And that's why we're seeing, suitability of regions. If you're already in a hot region, and you might already be, in 50 years, 100 years, as temperatures rise, you might be unsuitable for growing wine grapes. Whereas if you're in a cooler region, there might be more opportunities to grow different varieties. But one of the ways to mitigate this is through rootstock. And particularly, if you're in a cool region where it's wet and it's going to get drier, well, you've got options there to play with when it comes to rootstocks that are more drought tolerant, for example. And so rootstocks can help with things like improved tolerance to drought and heat, new pests, for example. There's a lot of rootstocks now that are either tolerant or resistant to some different pests that might be coming up and moving to new regions, or existing regions, I should say, from other regions. Tolerance to things like wet feet, managing vigor, and one thing that we're interested here is, can we graft a vine to a rootstock and see if we can have some enhanced cold tolerance, or maybe even greater resilience to changes in the climate that might reduce the cold tolerance. And so there's a number of local studies that we've been working on here. One of the big aspects of my research is looking at different genotypes, so looking at different cultivar, clone, and rootstock, and determining how it might impact vine performance and quality. And specifically looking at some of the interactions between the genotype and the environment and cold tolerance. Over the years, through the Vine Alert program, we monitor many different cultivars across different regions and across many different years. And we found that in some years, certain cultivars were very tolerant or much more cold tolerant than other years. And also their cold hardiness dynamics changed based on the winter temperatures as well. And I presented some of this in previous lecture series and so on. And so this is where, the resiliency part really comes into play. It's like, hey, can we find some cultivars that might not deacclimate as early? Or can we use different cultivar clone rootstock combinations that might be a little more resilient to these changes in temperature and have improved cold tolerance, as well as you want to make sure they still have improved, or at least have optimal yield as well as fruit quality. And that goes without saying. Everything, you can't have one without the other. And one of the other things that we've been working on have been looking at the use of plant growth regulators, and specifically looking at abscisic acid analogs, and how we're trying to improve the resiliency to some of these extremes in volatility in the weather. So if you can basically give a vine a drug that can help it get through some of these crazy extremes and keep things a little bit more normal, if you want to say that, that'd be a huge tool in a grower's toolbox. And you're not changing varieties, right? So when it comes to our regional rootstock trials, and this is looking at our clone rootstocks as well, we started these back in 2016. And it was through my colleagues, Dr. Ingalls and Dr. Kemp, through an NSERC CRD, and partnering with Ontario Grapevine Research Incorporated. And then most recently, it's been through the AFC CAP program and the agri-science cluster activity. So we first started in existing vineyards, looking at vineyards that had different clone and rootstock combinations. And then we moved into planted vineyards, and specifically research vineyards that had a number of different varieties and clone and rootstock combinations. And we started planting these in 2018. So we're just really starting to get more and more data from these particular blocks. And in these blocks, we have a number of different varieties, 5 different varieties, all looking at cool climate varieties that we're known for here, different clones, as well as on different rootstocks. And looking a lot at common rootstocks that we have here and seeing how they perform against each other in different years, and how they interact with some of these different clones or different varieties. And then also looking at some new rootstocks. And some of them include 1103 Paulson, 110R, and so on. Since we have a lot of different soil types, we're also looking at having these on different soils, like a heavy clay loam soil and a sandy loam soil. So our research vineyards are located on each one of these types of soil types. And then we're looking at all kinds of different parameters, such as vine performance, yield components, fruit composition, as well as even the wine potential. So I want to talk a bit about how some different clones and rootstocks can impact yields, fruit composition, and also cold tolerance. So this was work from Andréane Haber-Haché from some of her PhD research, and she published this in AGEV a few years back. And one of the things I want to point out here is that you have 3 different seasons, 2016, 17, 17, 18, 18, 19. And what we found was that in that Riesling, when it was clone 239, we found that Riparian Gloire, or was grafted to Riparian Gloire, it seemed to have better winter hardiness in most cases, in most years. But even the dormant period had an impact on the hardiness. And so some years, the rootstock had a larger impact than others. In terms of like how rootstocks can impact hardiness, it's thought long ago that it's more of an effect of growth and vegetation and this whole idea of balance. And so maybe a rootstock might have impacted the crop load and the balance, but all of these vines and all these combinations seem to be similar with respect to that crop load. But one of the things we also found, we looked at clone 49, so it's a different clone of Riesling. What we found was that it actually performed a little bit better on SO4 as opposed to Riparian Gloire. And so we do find that in some cases, when we're looking at all the combinations that we have, that in some cases there are some clone and rootstock interactions. And also, like I mentioned before, some yearly interactions. So in 2016-17, during those growing season conditions and dormant period conditions, it seemed to enhance the rootstock effect compared to some of the other years. So rootstocks seem to may have a larger impact in some years compared to others. Now this is some data that from 2021. In 2021 was a year where we had quite different conditions than in some other years, and it led to a lot of precipitation, and we had a lot of winter injury as a result of that year, which we're still mitigating to this day. But this was some data collected from one of my undergraduate students, Tyron Chung, and what we found in this particular research vineyard, and if we looked at one specific clone here of clone 548 of Chardonnay, we found that it had different impacts in terms of how rootstock was impacting the titratable acidity, cluster number, as well as berry weights. We did see some differences in Brix. And we saw some a little bit earlier maturation with respect to 10114 Riparian Gloire, but it wasn't significant. But it is to note if you are a grower or a winemaker in this particular year, in terms of how the interaction of Brix and also cluster numbers and yields may interact and impact your revenue. We also found that it did have some impacts in terms of titratable acidity. So I just wanted to show you that rootstock can have some impacts on some of the yield components, and in some cases it can even impact some aspects of maturity. Now, what about winter hardiness? And one of the reasons why I brought up Riparian gloire and how it may have had a little bit earlier maturity, it also had some lower yields as well. But what we found was that Riparian gloire had some greater maximum winter hardiness. And we see that, we also see that 10114 seemed to have a little bit earlier acclimation compared to some other rootstocks as well. And we found some differences throughout the dormant period with respect to how the dynamics of hardiness changed based on some of these rootstocks. If we're looking at different Chardonnay now, all grafted to 10114, so that was that one rootstock I had mentioned previously, and now this is just looking at one particular clone. And you can see in this particular case that 548 on 10114 seemed to be earlier in terms of some maturity levels, which is looking at soluble solids, even though the titratable acidity wasn't any different. We had some higher levels of sugar found in 548 on 10114. And it also had some differences in some cluster numbers as well with some of these clones, as well as berry weights. So you can see here some clonal effects and how these may, how using a different clone may impact, the quality of the fruit and the yields and so on, depending on your situation. And this is looking at a sandy site, by the way. And again, looking at these different clones, we do see some clonal effects with respect to some of these in terms of the winter hardiness. And you can see 548 on 10114. You can see that this was more winter hardy through most of dormancy. But one thing to point out is that it was the least winter hardy moving into April. So these are some things that we do find sometimes. And Marquette is a perfect example, and I'll talk about some of the research we're doing with Marquette because it can be very winter hardy, but it might lose that cold tolerance earlier. So this is kind of a bit of an example of early to bed, early to rise in this particular case. Now, is it consistent from year to year? We haven't. We're going through this season right now to see if we have consistent results, but just a snapshot for you to see. And speaking of another snapshot, here's an example of looking at winter survival and winter injury following that really wet year. And so we started walking the block, and we have additional data that we're going to be collecting this year and looking at recovery of all different types of clones and rootstocks for our major cultivars we're growing, and looking at how they're recovering and how much damage they had initially. And what was interesting here is if you look at this set that I have highlighted, this is all 667, so all clone 667, and it's all on different rootstock. And you can see that the Riparian rootstock on the site seemed to do better with respect to less damage in the vines compared to some of these other rootstocks, whereas SO4 was actually one that we did see more damage compared to some of these other rootstocks. And consistently, Riparian seemed to have better winter survival compared to some of the other rootstocks. Now, Riparian comes with a huge caveat. And so, and some of that is, yields might be lower, and it's going to be a lot more susceptible to drought. So this isn't a wet year, right? And showing you how a rootstock can really be adaptable. But in a dry year, in a prolonged drought without irrigation, we might not see this effect with Riparian. So I want to put a disclaimer on that. Now, rootstock considerations, they can impact hardiness, but it can be dynamic, and growing season can have an impact. And obviously the same thing with clones. But the best way is finding rootstocks that are adaptable to your site conditions and matching the proper rootstock to the site. It's going to provide you a lot more resilience than having a rootstock that's not well adapted to your soil type, for example. And one thing I haven't shown you here, but we have some rootstocks that we trialed in the sandy sites, and they've done lousy in terms of winter survival, and you see that result right off the bat. So proper rootstock choice is really, really important. And so there are a number of caveats. Some of these may be more drought tolerant, but as a result, they're going to be more vigorous, and they may lack hardiness under our conditions where we have a lot of moisture. In other conditions, as I mentioned with Riparian, they might be really good in some of our deeper moisture sites, but and have lower vigor, but they might be more susceptible to drought. And so there might not be a perfect rootstock, but I think matching that rootstock to your site conditions is really important, and to look at what's, these are where long-term studies are really important, as we're trying to do here, to see how over time which one is the best, has the best performance. And so I want to finish off with talking about some work we're doing with plant growth regulators. And so when I was talking about warmer conditions in the winter, this is one of the key things here, is that we can have warmer conditions during the winter months, and what it can do is cause the vines to lose cold tolerance quite rapidly. And so here's an example of a really warm winter that we had, where vines deacclimated about 15 degrees in a matter of 2 weeks, compared to a polar vortex here where it's very cold, and you see the vines did not deacclimate very early, and bud break was delayed. So one thing that we're trying to work on is looking at ways where we can use plant growth regulators as a tool to mitigate some of the effects of climate change and to enhance the production and the sustainability of a crop. Right now, they're very limited in terms of their use, especially in Canada. But just some examples of different plant growth regulators, and these are different families of hormones in plants, and what they can be used for. So everything from sizing berries, getting larger berries, coloring berries, improving maturation, and so on. And you can see that the timing of application matters as well. Just like I was talking about, climate can impact things at different phenological stages. The timing of when you put these on is also important. So one of the key ones that we've honed in on has been abscisic acid. And this is a plant hormone found in all plants, and this is a plant stress hormone. So it's a response, I should say, to abiotic stress. So typically drought stress in terms of involved with the closing of the stomates in plants, so to regulate transpiration, also responds to drought, heat, and freezing. So over the years, we've been experimenting with abscisic acid analogs, and so these were developed to help with seed dormancy and promoting seed dormancy and inhibit germination and so on. And since they've been developed, we've been working with colleagues and looking at these to enhance dormancy and to improve cold tolerance. And part of the reason is that they catabolize more slowly in plant tissues compared to natural ABA. They maintain high bioactivity, and they provide prolonged effects on dormancy and hardiness. And so here's an example from some research that we did with colleagues, and looking at this is in Washington, and you could see how we were looking at phenological stage, how the analog, which was this one here, this line that you see here, it delayed bud break following dormant applications, post-harvest applications. And what we found was a delay in bud break, a delay in phenology all the way up to pea size, the fruit set and to berry set when the berries were pea size. And then they seemed to catch up. So we found this would be a really cool tool to delay bud break and to maybe delay deacclimation. So vines are going to lose cold tolerance because of a warm winter, and this winter is no exception. You get a warm period in the winter, followed by a deep freeze, and you have catastrophic damage because the vines have lost their cold tolerance, and then they're not ready when the next round of cold weather happens. And so can these tools, can this particular tool, or like this drug, this plant growth regulator, can it delay deacclimation and bud break? And so we did additional trials here. This is in Merlot back in 1718. And you can see that the different analogs that we used, and these were different concentrations, we found that it delayed the deacclimation process. And late in the year, we were these were Merlot vines. They were up to 7 degrees more cold tolerant compared to the control. And so this is an example post bud break. Looking at these vines, all the leaves here, and you see it looks pretty scary here because it hasn't really broken much bud. So it might be a bit of an extreme, but we've been continuing to try to understand how these can be used to mitigate and mitigate deacclimation changes that can lead to freeze injury. And so we expanded this with not only Merlot, but also looking at Marquette. Marquette is a very winter hardy variety developed at the University of Minnesota. It gets very winter hard. It can be hardy below -30, but it will lose cold tolerance quite rapidly, particularly if we have warmer conditions. And so we're trialing the use of these growth regulators on these varieties to see if we can get that kind of effect in terms of delay in deacclimation. And so far, we haven't had the profound effect that we had in Merlot in that particular year. But we do find, if we are using some of the analogs, as you see in this lower line here, we are promoting some better acclimation, improving some cold tolerance, and including into April. A little bit less of effect, though, in most recent years, where we're only seeing about a degree difference late into the season. So we're evaluating and finding reasons why that might be the case, and we are getting some of these seasonal differences, but it's certainly something that we're really interested in using and pursuing to see how these may be impacted by, or how these can be used to mitigate some of these climate change effects, some of these volatility effects, extreme effects, and to produce more sustainable vines that are more resilient to these changes. So just to conclude, wine growing is highly impacted by climate. I think I showed you a few examples of how that can be. And our viticulture areas have a number of different variable climates, and they're also changing. Like we might be seeing more volatility, we might be seeing more in areas that are dry, getting drier, getting hotter, areas that are wet, getting more frequent hurricane type systems coming through, dumping a lot of water at key times like harvest. And so ultimately, proper cultivar and site selection is essential for premium wine production. And so with that, rootstocks, I think, are a huge opportunity for an adaptation strategy to climate change, and have been typically underutilized, I think, in many of our cool climate regions. And so, and I also think same thing with clones. As we're developing a clean plant program, and if we're bringing more plant material into our country and not relying on a single import from let's say France, and having only NTAV clones at our disposal and old ones at that, you know, if we get newer cloner selections, develop our own clonal selections right here in Canada, it could be really important for optimizing quality and vine performance. And that includes cold tolerance. So that's something that we could select for, I think, here in Canada, and we're moving towards more of that. Because these clones are typically not selected for cold tolerance, right? They're selected more for these morphological characteristics and so on. And then also select for either earlier or later maturing as well. So this is where these regional studies of evaluating material and then looking at potential clonal selections is really, really important. And especially looking at these different soil types. I just showed you data on sand. On sandy sites. I mean, it could differ when you're looking at clay sites and so on. So I do think this is importantly, increasingly important to look at these types of plant material. And this is why we're going to see more rootstock breeding worldwide, looking at more resilient selections. And then I think that moving forward, a really powerful tool is the use of plant growth regulators. I think it could be a really powerful tool to help mitigate some of these climate volatilities that we're going to see, and also extremes. And it gives you just a grower another tool in their toolbox. I mean, something you could spray on the plant. It's always the wish of a grower. Is there something I could spray on my vine to make it more cold hardy? Well, there might be. Right? And so that's something that I think is a huge way of building resilience into some of the varieties that we are currently growing without changing everything in terms of what we're known for, what we're branded on, and so on and so forth. And so this is, I think, a potential solution moving forward. So part of my research is going to focus more on studying these and seeing how they impact cold hardiness mechanisms and so on. So partnering with colleagues here in biology, as well as colleagues outside of the university to study this in more detail. And so I'd just like to acknowledge my colleagues. I also have to acknowledge Dr. Sue Abrams, who we work with in Abazyne with the epsidic analogs, all different lab members and funding agencies that have helped support some of the work that I've talked about today, and obviously all the partners that we work with to provide this research. So I think thank you all for attending, and I think all of my partners and colleagues who help me on a day-to-day basis. So thank you very much. If anyone wants any references, I have some there too. Some of them are some of the thesis projects from my students, but down the road you'll see these published somewhere.
Any questions?
Yeah, happy to take any questions.
And well, thank you so much, Jim. And our lecture series continues next week when we will welcome Dr. Amy LeMay, who will focus on the role of knowledge mobilization in the adoption of best practices in horticulture. So we hope you'll join us here in person or online then. Thank you.